My name's Frank Kelly, and I'm here with Giles.
Hi.
So we're talking about you could say, a small project we've been working on that puts data science to a good cause, really. And it's a cause that I've been personally affected by, and we think it's very much worthwhile. So we'll explain a bit about what we've been doing. We're going to talk a bit about the way we've looked at this problem and identified features, and then built some models, and then tried to draw conclusions. And we'll share some of our findings and results. Okay. Sure. Is this better now? Okay. So what is our goal with this? So ideally, we want to develop a way, using data, to diagnose Alzheimer's disease as early as possible. So a little bit of background about Alzheimer's disease. It affects millions of people around the world. It's the most common form of dementia, so 70% of dementia is Alzheimer's, usually. There's quite a shocking statistic. In the UK, there are about 800,000 people formally diagnosed. Sure. Is that better? So in the UK, there's about 800,000 people who've been formally diagnosed, but there's perhaps 1 million more who have symptoms of Alzheimer's, and yet they don't really know, and they may go all the way through to sort of chronic stage of Alzheimer's without being formally diagnosed or treated, which is quite a shocking situation. I'm sure you'd agree. So, and it's going to get worse, unfortunately. If you look at population demographics, so the chart on the left is showing that as populations get older around the world, so the ratio of people who can care for people who have things like dementia is diminishing. So that's the ratio of dependence on the left. And on the right, a country like Japan, you're going to see, the number of people suffering from something like Alzheimer's or dementia is going to triple. So this is a huge problem. So who are we? Well, I've introduced myself and Giles earlier, but there's a couple of other people working with us on this. You could say it's a part-time side project. So we get together once every 3 weeks, or if at best every 2 weeks, over online. One of us is in Canada, the girl there, Maya, and there's a chap on the right, he's in Spain. We're both in the London area, but we managed to get online and do a little bit of hacking and playing with data. And so it's really, this is just a project on the side. We're not no major promises about what we can achieve with it, but we're here to share what we've done. So in terms of our thinking, so Alzheimer's disease today is usually diagnosed by a trip to a GP. So starting with, they look at your medical history, they'll perform some tests, and it's a one-time event. So you come in, you have a test, and you've suddenly got Alzheimer's, you're diagnosed, and eventually you can go up to doing brain imaging and eventually dissecting the brain to really confirm that Alzheimer's has taken place. But we know that Alzheimer's is really it's a gradual decline occurring in the brain. And so the diagnosis period is usually between, say, 13 years and 6 years before the person dies. But if you look, it often happens up to 20 years before that the conditions start to happen. So there are many benefits for earlier diagnosis, not only in terms of the individual and their families, in terms of their planning and responsibilities, and they're reducing their anxieties. Also, there are interesting developments in terms of drugs that may be able to slow down the effect of the disease. And if more people can start to be on drug trials earlier, then I think that bodes well. And a potential cure, we'll be closer to looking at cures and really ways to tackle it. So looking a bit at our, how do we start out? So we thought we'd look into the domain area, get a bit of knowledge before diving in to creating features and doing some analysis. So Alzheimer's really manifests itself by, well, the leading hypothesis is that you have these protein plaques that accumulate in the brain, and they really disrupt communication between cells. I'm not sure whether they actually kill cells. I'm not a domain expert. I understand there's been some experiments when they managed to stimulate neurons in the brain, and memories were able to be brought back afterwards on mice. So I'm not sure how, and I don't think even the leading experts entirely understand the cause or the impact of the disease. But what we do know is that it starts in one part of the brain, which is the hippocampus. So this is where our recent memories are formed, so the earliest symptoms you'd see is short-term memory loss, difficult to people having trouble recollecting certain recent events, and then the disease progresses through the front part of the brain and moves on to areas such as language processing, and eventually goes through logical thought, emotions, the senses, and onto sort of older memory. The rate of decline, we know it varies for men and women. That's been recently discovered. But eventually, of course, this will lead to full shutdown of the brain, because even the sort of life support systems will be eventually shut down. So how do we turn this into a data science problem? Well, we took all the symptoms that we could read about in various papers, and we tried to match them roughly with this timeline. It's all very approximate. But we tried to think about where we might get some data, and we started with the idea of written correspondence, because it's already digital, easy to access. So in terms of what we could pick out from people's written correspondence, we selected these features. So it's also trying to find features that would tally with the earliest symptoms and that part of the condition. So these three, so language problems, so memory issues, and change in sentiment and mood were areas we decided to focus on. So previously, I don't know if some of you come to the PyData meetups. I did a lightning talk, and we started out by picking up a single Alzheimer's sufferer's emails and doing some analysis. So we converted emails to vectors and eventually counts and numbers, and extracted a few features. So here we got readability over time. So the age of the patient was between 78 and 82. And yeah, she's actually the grandmother of one of the people collaborating on this team. The thing is, whilst we saw there's some example emails there that we were looking at, for example. We saw some sort of trends over these 4 years. It's hard to really be conclusive. And looking at email in general, we made a lot of inquiries, and we spoke to some organizations about getting access to volunteers' emails. The problem is there's a lot of security concerns, and people actually often delete their emails. So we decided to change tack slightly. So I'm going to hand over to Giles now. He's going to talk about our approach.
Okay, so one of the big issues with email is how do you get hold of it, and that's pretty tricky. So we looked around for other places we could get the data from, and the Alzheimer Society UK forums was the most accessible place where we could get a lot of written data. produced by both sufferers and non-sufferers of dementia. So we've used the I Have a Partner with Dementia subforum as our counterpoint to the I Have Dementia subforum, which we hope will allow us to control to some extent for age and education of the subjects. So there was an initial XML scraper that we used, and we rewrote this later into Beautiful Soup, which basically made it easier for us to get more content from these posts. So we scraped 2 subforums, 3,600 threads approximately, and about 30% of those were started by sufferers of dementia, or at least that was the subforum they were in. And 78,000 posts. Unfortunately, the majority of those, as you might expect, from non-sufferers, or rather in the non-sufferers, the partners forum. So we grabbed the post content, the metadata, the user metadata, and output that lot to a couple of rather sizable data frames. Well, sizable, not perhaps in terms of big data, but that gave us something to play with. So Beautiful Soups made things very easy for us. We did a little bit of text cleaning, but not very much required, just the bare minimum to put things into NLTK, basically. We removed the quotes from the posts. You can imagine that could contaminate any signal quite significantly. And use regeps just to tidy stuff up a little bit, nothing complicated. So you've got the user metadata frame, or a small chunk of it, up on the right there. You can see that we have issues with some posters post a lot, and other posters only post once or twice. So we do have issues with various biases in the data. And the actual post content with the record of the thread it's in, the post count is very important. So the first post in the thread is the one that we prefer to use to classify a user. If they've started a thread in either subforum, we can probably assume that we can classify them appropriate to that subforum, whereas if they're replying, then they could be a dementia sufferer replying in the partners forum, or vice versa. So that's pretty difficult. So labeling the users is a bit of an issue. Right. Okay, actually, Frank, this is yours, I think.
So yeah, we determined a source of data, and what was our strategy? Well, we wanted to engineer some features that would match the symptoms I've described, and we wanted to somehow aggregate these posts in a way that could be analysed and have features extracted for them in a meaningful fashion. We also wanted to select a few models and do some classification. So something on user classification here. I think, Giles, you wanted to talk about that?
So how do we label the users? So unfortunately, individual users rarely, fortunately, individual users rarely start threads in both subforums. If they do, we discard them. So there's only 12 in that case, so we don't lose too many users. But replies in both subforums are common. So if we look at some examples here, we can see that the first user in this frame, 18 Roy, well, he's only posted in the partner forum, so that's fine. We can classify him as a partner. He started the thread and he's replied a couple of times as well. Mindy, that's fairly clear. She's started 13 threads, and although she's replied to a few posts in the partners of the dementia sufferers forum. She's replied to a lot more in the partners forum. So we can confidently think that she's a partner. 2J's, so this one, if you were not being too cautious, you would classify as a partner of a dementia sufferer because of the ratio of posts here. But in fact, we've taken a cautious approach, and it's a compromise between the quality and the quantity of data we have, but we've thrown out anything that's ambiguous like that. 53 Sharon has started and replied to threads only in the dementia forum, so we're pretty confident that's a dementia sufferer. And 60's child is a really difficult one because they haven't started any threads and they've posted almost equally in each subforum. So unfortunately, that's data that we wouldn't use. So in summary, we discard users who start threads in both forums. We also are currently leaving out users who replied to threads in both subforums. We could use those that predominantly reply in one subforum, but for reliability, it doesn't give us much extra to work with, so we just bin that data. So that gives us, unfortunately, two quite biased groups of users. We have a lot more partners of sufferers, but it's something to work with. So over to Frank.
So once we'd established more or less who a user is, whether they're a sufferer or a partner, we weren't entirely sure. We didn't manually go through every single post, as Giles said, but we got we were fairly confident about our initial data. We decided to design some features. So to start with, we just put some very basic features to do with counting words, counting sentences and unique words, word count. And encouragingly, if we plot a histogram of posts, we see differences straight away. So we see that sufferers are generally, they seem to be writing longer sentences, which sounds strange, but it might be, we figure, because they're not maybe using punctuation as often as their partner, for example. So you see a sort of a wider spread, more variation. There's things like, sentiment. There's a package called text blob you can just pull out, and it's a fairly basic procedure. You're able to analyze the sentiment of every word in the sentence. So we saw that also, quite strangely, the dementia sufferers tended to have more positive sentiment than their partners. Now, it could be because of their sort of state of mind. It could be because their partners are more worried than they are. There could be many other reasons. It could be just noise in the data at this stage. But that's sort of initial patterns we're seeing. So a couple of other features, things like go-ahead words, this sort of thing. We wrote a function to sort of count these in the post, because that's a feature of Alzheimer's sufferers, according to several papers. So we looked into, with Alzheimer's, you tend to get a loss of lexical functions, or vocabulary tends to diminish. And people tend to use words out of place, so they might use words that they've come up with themselves, or words that really aren't relevant to what they're talking about. And then there's general comprehension of what they're saying. So something like a readability metric should help us with that. So readability metrics, we found quite a good package called readability LXML. It runs all of these metrics for you straight away on the text. And here's a couple of them plotted. So what we see again is reflected once more. So there's greater variation within the dementia set in all of these metrics. But there's a tendency for, strangely, the comprehension to be so it's slightly harder to read. So the readability metrics are aimed at matching sort of an age group, as in people aged 13 to 16 would have no trouble reading this, or no, it's actually only people aged 10 to 13 could read this. So we found that the dementia text was actually harder to read. So without trying to read too much into the reasons behind this, we explored the data a bit further. So plotting on two dimensions, these are individual posts plotted. So these are different metrics. I don't know if you can read the axes, but there's things like Dale-Chow readability, which is made up of the number of difficult words and the number of words per sentence. So you see interestingly and encouragingly, you see the dementia, the sort of increased variation. It's almost like the dementia sufferers' posts are sort of breaking away from the norm, as it were. That's what we could see. So after exploring the data sort of post by post, there's a memory-oriented feature as well. So we just did a very simple comparing. We just used pandas group by and ordered all the posts, and for each user we semantically compared the post with the previous post using cosine similarity. So just comparing two vectors there. And I tried another one, part of NLTK package, the edit distance, which I think is related to the number of characters you'd have to rearrange in a sentence to make it match the previous one. So this is to do with people repeating themselves, basically, and let's see if we can quantify that, measure that. So thinking about in terms of how now we have the feature set, what are we doing here? Are we trying to make a prediction of whether someone has Alzheimer's, or are we trying to just explain the causes? Well, in fact, we need to undertake both approaches. So we start by training a classifier to find out which variables influence Alzheimer's that we can see, and this will be explanatory, and then eventually we need to work on a predictive power in terms of determining, when is Alzheimer's starting to happen in somebody that's an unknown. So in terms of our initial explanatory modeling phase, we started by aggregating the user's data. So we took median values, and so for each user we took all their posts and worked out the median of the relevant metric. And we did some sampling. We had a holdout set as well, and this is
the fire alarm system is operating in City Gate House.
There you go.
Do not use the links between these buildings until further notice.
Okay, so the model results. So we decided to group our features into different.
The fire alarm system is operating in City Gate House.
Just carry on through that. So the first group were the sort of miscellaneous features. So we put sentiment and the first metrics I showed you. So we just we ran a few different classifiers, and the results were not that great, as you can see. This ROC curve is not brilliant. The sentiment came up as top. This seems to be a key sort of differentiating factor. Then we looked at the memory features, slightly better, so 63% accuracy, but the precision isn't amazing. And it seemed to be this cosine similarity metric. We tried the mean and the standard deviation to account for the fact that we'd aggregated the data, and just the mean on its own wasn't telling us much. That came up on top. The readability features, once more aggregated, not so great again, so 59%. But this Dale-Chow, this readability, the one I plotted earlier, this is of feature importance. We were just using the random forest function to be able to explain the importance of features. It came out as a really important metric. And then we did some part of speech. So breaking the sentence down, determining what type is each word. So we looked at adjectives, nouns, and pronouns and verbs, and we're able to calculate a rate, as in how many verbs divided by how many words in a sentence within a post, and then aggregated over all posts for that user. And so, got 2 minutes left. So yeah, we found that this support vector machine radial basis function seemed to do the best. But again, not brilliant. And when we combined all of the features into one model, so we're getting about 63% accuracy, and there's a sort of a mixture of between readability, sentiment, and memory features coming up. We had a slight change in tack. We decided to classify posts and not users, but the problem is we found that there are many more partners than dementia sufferers on the forum, and in general partners were writing 3 times as many posts as dementia sufferers, so we had to sort of do this double round of sampling so we'd even up our data set. But that paid off, and we got a sort of accuracy of up to 68% with a random forest classifier. And this is the only slide where I'm brave enough to put a confusion matrix on, because the results were looking a bit more encouraging. And the memory feature came up top. So just to wrap up, memory-based features seem to do the best, and the best performing individual feature was verb rate in the case of aggregated data, but if on individual posts it was cosine similarity to a previous post. And this falls into line with what we determined in terms of early symptoms. So we want to look into many future avenues, including grouping of users, improving every phase of this pipeline, so getting better data to start with and classifying users to start with in a cleverer fashion. We want to collect more features. We want to do different kinds of classification and move on to the predictive element, which will probably involve some kind of time series analysis. So we thought about, we noticed this dementia sufferer here. They've been posting a long time on this forum, and we see like an increase in the variance. So maybe that's going to be a way to detect for certain features. It might be a change in the mean, like a ramp, that sort of thing. So it's something we want to look at. So I think I have to finish now. We're all done. So thank you for listening to us. We hope we've sort of given you an introduction to Alzheimer's, some of our initial findings from this very small side project. It's a tough problem, but we think it's worthwhile. If any of you would like to help and you think you can do this a lot better than us, then please get in touch. You can come and chat to me afterwards or drop us an email online through the links. Thank you very much.
Well, thank you very much. That was fantastic. So yes, we don't have a roving mic, so just try and speak up if you can.
Yeah, sure. I think you mentioned that the importance, you always use the random forest, right?
That's right, yes.
You get the importance rankings. Do you know how that relates to, if we always, it's one particular classifier, does that also apply? Or could there be a different importance for different classifiers? That's my question.
No, it was purely through ease of use in our case, so it probably doesn't relate to the different classifiers. But yeah, certain classifiers we found that aren't very good for a sort of explanatory problem. They're more sort of a black box, give them some inputs and get some outputs. So we were just using the random forest as a way of just comparing the groups of features as we went through. That's true. So somewhere around 80% or would be great. The key is to just, eventually this might turn into an application. So it would just alert people. It might say to you after reading your emails for a few months, it might say, well, can you make an appointment with your GP or just go and have a chat? And so I suppose it's better to err on the side of, say, 80-90%.
So this is really more of a curiosity than something deployable, and it's a very long way off that. Obviously, in anything medical, any false positives or any false negatives are a big issue and tend to scare people. So, there's massive doses of caution would need to be applied to anything that comes out of the other end of this.
Sure.
So you mentioned that verbs, they use verbs a lot. Alzheimer's, people diagnosed with Alzheimer's disease use verbs a lot less. Is that what you discovered as a ratio? I think it was on the previous slide.
I think that was feature importance of the different features, which is not the same as how predominant those features are, the nouns and the verbs. And again, maybe it was.
Well, it was. Where did you see it earlier on? Did you?
Is that?
It was there, yeah.
But it's just determining that we don't know whether it's more or less actually. It's just determining that it was important in the classifier.
So my sort of prediction for the kind of text that any kind of dementia patient would use, including Alzheimer's, would be that they would use more category general words to describe natural kinds. And I was wondering if you're interested in looking at that kind of thing or have looked at that kind of thing.
Definitely, yes.
What did you find?
So are you working in this domain? I mean,
not specifically with Alzheimer's dementia, but with another type of dementia. And people who have most types of dementia are likely to use like a word like animal, for example, to describe a dog,
right.
which a neurologically healthy person would not do. They would say the specific word dog, or even Labrador or whatever. And I was just wondering if you looked at what kind of words they use when they talk about natural kinds.
We haven't gone into that level of detail.
Mm-hmm.
The one thing that comes to mind is that they did tend to use more difficult words, so fewer common words. I don't know if that tallies, though, with what you're saying.
Okay, so when you say, you mean just words that are less frequent?
That's right, in the English language, yeah.
Okay, that's interesting.
Thank you.
Thank you.
Oh, at the back again.
So a question regarding the sentiment analysis. I think you use just one library, right?
The text blob, yeah, that's right.
What's your experience with that? Have you looked at other scientific analysis techniques?
The experience was that it was very easy to use and to get set up. You don't, it's got its own pre sentiment analyzed vocabulary, so you can just throw it a sentence and it'll return the sentiment.
Have you looked at alternatives?
Not as yet, but it's on the list. Yes, yeah. Do you have any recommendations? Cool. Okay.
Lady at the front.
Have you compared the data you got for dementia people and partners to the results for people that don't have anything to do with dementia? Like, I mean, for example, for sentiment, I would expect the partners to be a bit maybe negative because they're worried, but maybe normal people would do the same as dementia people.
Right. Yeah. So we have thought about that, and we want to add more forums so that are unrelated. The thing about the partners is that they're of a similar age group, usually, to the dementia sufferers. So there are presumably factors that occur just as standard decline during old age. So that was a way of normalizing that. But yeah, you're right. They're going to be worried, and that's why they're posting 3 times as much, maybe. It's definitely a factor. So Yeah, so at different forums, there was one like I'm a carer of an Alzheimer patient, and yeah, we may just pick some completely unrelated ones just to see how the features tally. Thank you.
Probably have time for 2 more questions, and then I'll let you get fed and watered. So,
Thank you very much. Very interesting. I've looked at a similar thing where you look at the feature importance,
Sure.
and obviously the knowing bit doesn't say how it's changing your response. So I don't know if you've done any work on building on how your features are changing your classification.
No, for now we've just used the simple the output from the random forest in scikit-learn.
Yeah.
The only thing we did was to group the features initially and try them out in separate groups. So that would give us an indication of the sort of main areas. But you're right, we should do some more careful feature selection and observe the impact on the model directly. Yeah.
What would you do? You just run it. I mean, how would you? Because I can across the same problem. How would you devise such a test? Just run like data with, we just change one feature because there's interactions a bit more difficult.
Yes. Yeah, there's various approaches. Yeah, can have a chat afterwards if you like.
I just want to add to that, we've done very little in the way of optimization. We haven't done proper hyperparameter searches, very much trying to sort out the methodology, and then we've just thrown the data at classifiers and seen what's come out with practically no tuning. So it's not very sophisticated at this point.
So we probably have to wrap things up. Can we have another round of applause for our great speakers?